Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at allocating memory in a class, and we're going to see some tips and tricks there. If you're already comfortable with allocating memory and dealing with it, you might want to skip this. I'm just adding it because we're going to look at things like move constructors, and they will make much more sense in future tutorials if we have a test class that actually allocates some memory. So I'm going to give this a private section here, and I'm going to create an int pointer which I'll call _p buffer, p for pointer. I like to call member variables m underscore something or other, and the end stands for member, but a common convention is just to start member variables with an underscore, so I'll follow this here because you definitely will see that. Let's also give this a static const int size, which I'll set to 100. That's going to be the number of ints in our buffer. This isn't going to do anything really meaningful, it's just a kind of demo. And then in our constructor we can actually allocate memory for this buffer, which we could use for some purpose or other. Let's say _p buffer equals new int, and put in brackets here and put in size in the brackets. Now there are three ways, well, at least three efficient ways that I know of to allocate this to set this all to 0. So a common thing that you want to do if you create a buffer, you don't necessarily always need to do it, but often you want to set all the bytes in that buffer to 0, and that does tend to help you reduce bugs if you do that, because then you know that they should be 0 until you've written to them. So three good ways to do it. I'll start with a way that I first learned when I started learning C++ in like 97 or so, 1997, and that is to use memset, which you can usually find in memory.h, and there you just specify the thing that you want to 0. It's got to be a pointer, and then the value that you want to set all the bytes in that buffer to. So not the actual ints in this case, but the individual bytes. There's going to be probably 4 bytes to an int, and of course if we set all 4 bytes of an int to 0, then the result is we're going to get a bunch of 0 ints with value 0. And then you need a number of bytes, so we can use size of here, that are in the buffer in total, size of int times size. That's one way to do it. A lot of people say that memset is sort of kind of prone to introducing bugs. You can overwrite the end of your buffer by mistake or fail to fill it properly if you get this bit wrong. But it's a very handy tool to know about. Now another way, which I only learnt about last week, and I don't know why I haven't come across this before, but in this case where you're allocating a bunch of ints, and probably this works for chars and longs for all I know, and this may well work on your compiler, is you can type just round brackets here. I think this might be a C++ 11 feature. I need to check on this more really, because I'm surprised I haven't come across it previously if it's not. But you can try it and see if it works on your compiler. I'd be interested to know. Now if you're using C++ 11, which I am here, I've turned that on in this project. I've turned on C++ 11 support. One way that definitely works is you can put curly parentheses here. An empty pair of curly parentheses right here will 0 all the bytes in this buffer, set them all to 0, so that's a really handy thing to do. Now in this, well, the first thing we should probably do now is to make sure we delete this memory, because we don't want a memory leak. So I'm going to go to the destructor, and let's just use delete, and we need to use the array form of delete, because we've got an array in effect here to delete the memory associated with that buffer. In the parameter version of the constructor here, well, normally what I do is in C++ 11 we can call one constructor from another constructor, and we can make use of that here. But I don't want to do that because I want to keep everything separate here, just to make it as clear as possible what's going to happen in the next tutorials. But in this case, so normally I'd call one constructor from another, but because I want to keep everything separate, in this case I'm going to just repeat this code. And in C++ 98 you can't call one constructor from another, you can only do that in C++ 11. So in 98, it's common to have an init method, which all the different constructors call, just a method, a normal method that can be called in a constructor. I'm going to make use of this parameter here. Let's just set this equal, just to give it something to do. Let's set all of this equal to maybe the 7 times table. So let's say underscore p buffer I equals 7 times I. That'll do. Now in the copy constructor, we need to, in that case, we need to allocate memory and then copy the bytes from this other object that's being passed in here. So one efficient way to do that, and there might be a more efficient way that I don't know about, but I haven't come across it, is to use memcopy. So again, we could use, it's probably included already because we've got vector and stuff, but it should be in memory.h or possibly memory. Let's try memory.h. So I probably could have got by without including this because it's probably included in these somewhere. And let's just do here memcopy, and the first parameter is the thing you want to copy to, and the second parameter is the thing you want to copy from, so other dot underscore p buffer, and then the number of bytes that you want to copy, which is going to be size times size of ints, because we've got size number of ints. So that should do the trick. And these parameters are in the same order as they would be in an equal sign. If we were setting that equal to this, then we'd have them in the same order, so it's the destination first. We've got an assignment operator here that could call the, the copy constructor could call the assignment operator. That would be a good way to do it. But again, just to keep these separate here, I'm just going to copy this, and we're going to do it this way. And that's basically it. We shouldn't get any memory leaks. You can use a tool that detects memory leaks. There are various tools around that will do that. But here, I'm not seeing any errors. And if I've got this right, there are no memory leaks. But of course, the thing about memory leaks is it's often hard to spot them unless you run some sort of special tool. But we've taken care here. And this class, whenever it's deleted, it deletes the entire buffer. And the other thing to watch is that you don't get memory overruns or even underruns. But size is the number of ints in this buffer, and each int has size of an int. So this looks good to me. Okay, so that's it for this tutorial. In the next tutorial, we're going to go on, I think, to looking at R-value references in C++ 11. So until next time, happy coding.